This is Spline Madness. Hello and welcome to another Thinking Particles tutorial video. In this video I use Thinking Particles 7.3 Service Pack 1. If you did not update to the latest version yet, please do so now. I will explore in this video how we can create splines with MEL and how to use the spline pool node of Thinking Particles to control the look of the individual splines. I will also talk a little bit about how multiprocessing works and why it is relevant for MEL setups. So let's dive right in. Before we start with the video, a little reminder, everything you see here is a non-scripted video, so things happen as I explore it in real time in 3D Studio Max. The scene here is made out of these particles in a raster. And let me just bring up our Thinking Particles user interface so that we can explore how we created this scene. This scene is built out of a born node, so that creates just 200 particles at position 0 if we don't supply anything else or move the particles. And I connected the generator output of this born node to the generator input of the expression MEL node. Let's have a look at the code. Little script, very easy. We place these particles in a raster. So how did we do that? First, as I already mentioned, we create 200 particles here. So those 200 particles are all created at the origin at 000. In our code, what we do here is we have some variables or controls we created. We have, for example, the group to access the particles. We have the raster up here where we can say, okay, that's our distance between particles and our dimension, how wide and how long these X and Y axis should be. So these controls are created with the command input description, and then I just tell it what should it be. So what we have here actually is our inputs where we select the group, the particle group, so that we can later access it from the code. Then we have the raster value. Let me just select that. Our raster size, so I can just turn that maybe to 15. Then we have a closer, tighter raster or 5 and everything is calculated on the fly, so we get the amount of particles, and if we have not enough particles, we can't fill the raster with these settings. And the same here for our dimensions in both areas. Let me just go back here. So this is all happening with our MEL script, so we can control the dimensions. And what we do here is it's practically very simple, but there's something going behind closed doors, so to say. Our first input here, up here, let me just make that clear. So this input here, let me select that again, is our generator input. And if we look at our setup, our node setup, we see this generator input comes from the born particle node. So we connect the generator with this input. So our generator input is the first input we created for the MEL node. And whenever a first input is created, that means everything that's inside or supplied by this input will be processed in a massive parallel manner. So everything runs in parallel. We automatically spawn multiple threads to go over the data supplied by the first input. And this also decides on the global variables, which values you find in there. So the first input is very important and decides, or lets you decide, what you want to process in multiprocessing or multi-threading. So keep that in mind. Let's continue here with the code. It's very simple. So, and we'll use these particles to draw some splines. So the next thing we do here is we just calculate with simple math how many particles will fit in a row in X and Y. So we just calculate based on the dimensions and the raster size how many of these particles actually will fit in this box. Then we declare some variables x and y, and we declare also a variable, a vector for position. And here we come to the specific multiprocessing method we have here in MEL. So in multiprocessing, that means this code is running actually in parallel multiple times. So if you have a 64 core machine, this code will run 64 times at the same time. So you will have 64 times this code evaluated. And that gives us a little bit of an issue that's naturally happening because of multiprocessing, because we are going through the particle pool created by our born node. We are accessing all the particles in parallel, so we don't know which thread has which particle right now. Because we don't know that, there are some functions where we have global variables, and these global variables are, for example, ID underscore. And if we wanted to learn more about what this actually means, we can just click our caret or cursor here and press the selective help button. And that will bring us to the online help and explain what this means, or this global variable means. And that's the iteration index for the current thread. So this ID underscore variable is fixed and filled automatically from the amount of threads that are happening. So now if thread 20 is working on particle 20, so to say, we can use this information to say, okay, my particle 20 should go here, for example, or there or there. So this is what we use here to calculate the y-axis, where we say, okay, particle 5 is processed here. So with this method, we don't need to know which particle we have. We just sort them naturally with calculating, okay, particle 5 should be there, particle 10 should be there. And this is also good later on when we want to create splines, because they are in order when they are created. But again, all the multiprocessing will play some tricks with us, so we have to be careful how we create our splines in the end. So let's create some splines here, and we're doing that by adding a new input. So to handle splines, we need a spline pool. So let me just create the spline pool node. We'll bring up the spline pool node. Now we need to connect the spline pool with our input. We don't have one, so we need to create a new input. And we do that by just telling it, okay, I want an input. Autocomplete suggests me already the right one. And I'll say, okay, spline pool. I want to have a spline pool input, and the port type should be a spline pool. And that's all I need to do. Now, when I press the compile button, we have a new input for our node, the spline pool input. Now I can connect the spline pool, and we can already set up some parameters. Let me just do a 1 millimeter size for our spline. So now we have a place, so to say, where we can store spline information and handle them and add knots for our splines. So now that we did that, we can access the spline functions by just typing, for example, when we wanted to do that, let's just say we go in here and we just type in spline. It will automatically suggest some functions I can use with the spline pool. So for example, we have the spline pool in spline function, and this is the one we want to use. And I'm going to use this spline pool in spline function. Let me just type that in here so that we can have the spline pool in spline function. So what I did here is, and that's the important part, is we are creating a spline. And we've just for the information, we click in here, press our selective help button, and we can get the information. So this is what we need to supply to create a spline. We need a spline ID, and we need an ID we want to add, the particle we want to add to the spline, or the knot that should be added to the spline. So this is what we need as information here to create a spline. And at the very end, there is also the insert ID, and that's the sort ID. So this allows us, once more, because we are called in multi-threading, we don't know which particle is created, and we don't want the splines to get connected criss and cross. We want to connect them in order they are created. So let's say when they are created in this order or in this order, we want to create the splines in these directions or the spline in these directions. So this is why we say, okay, sort it by x-axis. So I think we already have everything we need to create actually splines. So I'll just reset the simulation, and there we go. We have our splines. We can see the splines are very thin. So let me just go in here and maybe use 5 or 2 as a size. Yep, let's keep it at 2. So now we created splines in this direction. But how about if I wanted to create a real grid or raster, and I want to create splines in this direction as well? So we can't use the existing knots right now, because a spline knot is always locked to a spline. You can't have multiple spline knots floating on different splines. So we need to create new particles and work on those particles as well to get the spline knots. So let's create some new spline knots. And what we do here is, just after we created our knots, we are going to create a new, let me just go in here. We are creating a new bunch of splines here. So let me create at the same position. I'm using the position we use here. So I'm reusing the same particles at the same position to create our vertical line. So I create another particle here, and the particle created automatically gets this particle ID assigned. So then I can use the particle ID to create our vertical splines. So let me just go in here and add this. But now I'm using the x-axis and I'm using the y order. So we're creating the splines in this direction. So now if we compile that, we have no errors, so all is fine. I'll reset the simulation. Now we get our spline raster as we wanted it. So now we have multiple splines, splines running in this direction and splines running in the other direction as well. So how about if we wanted to control the size or thickness of the splines also with MEL? That's very simple and really fast to do. We can use just the particle size to control our spline thickness. So when we create the particles, so let's say here, so we created our particles here. I'll also create, let me just grab that here. We also create with this code, I'll set the particle ID, the data size. So I want to change the size. And I use, again, a little trick. I use the ID, that's the number of particle that is worked on, as my size. And I want to have a minimum size as well. So now what we will get is, for our axis in this direction, we will get this size here. So now we control the amount or the particle size. And if we are not happy with that, we can make it maybe a little bit smaller if we wanted to. Then we have it like that. And the size increases for each row. So the next thing is we want to create for the newly created. Remember here we create a duplicate set of particles for our other axis. And we want to control the size here as well. So I'll just use the same values, same call, but now I'm setting the newly created particles. We just compile, go back, and now we have the grid in multiple dimensions. We set in X and Y the size, and it starts increasing to this left side hand. And also it starts increasing from here to here. So now we have in all axes, we control the size of the splines. So this is a very powerful feature we have here in MeL. You can control how to create splines, where to create splines, and it's very simple, easy and efficient. Just with a few lines of code, you can create really powerful visual effects. By the way, thinkingParticles 7.3 comes with a lot of sample files. In total, we have over 400 sample files. We have a lot of sample files for MeL alone, including this scene you saw here. So you can recreate this scene, go along with the video here. Just download these raster spline scene, or you don't need to download it, it's automatically installed. Just load the scene and walk it through and try some things. Click into the code you want to explore, into the variables you want to explore, press the as help button, and you get the information and know how to use it. I hope you like this little quick video, and I hope to see you again on our next videos. Thank you so much.